So first little section here is meant to be some vocabulary review. So looking at the top of the page, prisms. Okay, a prism have two parallel bases and lateral faces are rectangles. So between this triangle, that's kind of translated. So imagine that's stacked a ton of times from there to here. I almost like to think about this as a wedge of cheese, okay? From the front to the back. That if you slice the cheese a bunch of times from the front to the back, you have a bunch of slices here that are all triangles, okay? So that's how we name it. It's a triangular prism. Rectangles. There's a rectangle in the front. And if we slice this vertically, kind of going back, you have another rectangle in the back. Here, the front shape is a pentagon. So this is called a pentagonal prism. So again, prisms are named by the polygon. Okay, so it's named by the polygon you see. Now, if you only see rectangles, then it's rectangular. Okay, a lot of students get confused on this. If you take a look at the bottom of each of these shapes on the base, okay, that base shape down here appears to be a rectangle, but that's not a rectangular prism. This only has rectangles, so that is a rectangular prism. Again, each side face to this prism here is a rectangle, but we name it again by that pentagon. And I'll be talking about that a little bit more in class when I see you all. So the base does not mean the bottom. Right? The base shape is a triangle in this case, a rectangle in that case, and a pentagon in that case. So that's shape of the base. So kind of naming some of these here. First one, if all three sets of sides, the length, the width, and the height are all equivalent with those double dashes, this would be named cube. Okay? Think about a dice. Okay, a six-sided dice that you would roll in a card game or Yahtzee that you're playing. Okay? That's a cube. This shape here, this wedge, okay? Think about maybe a doorstop. That's called a triangular. Here, all sides of the shape are parallelograms. This is called a parallelopiped. Very fancy word. Parallelopiped. This next shape is actually sitting on the bottom and on the top. Okay. You might see some kind of candy packaging in this shape. And I'll bring in some examples for class this week. This bottom part here is a hexagon. So this is a hexagonal, I'm going to add the word AL, prism. So base shape is a hexagon. This next one is also a triangular prism. Okay, just not going to rewrite the word. This here, I'm going to call it a square prism, because the base shape is a square. And again, identifying these bases are important. You'll see why in a second for our formula. Okay. Here's another little wedge shape, kind of just situated a little different. You might think of this as a tent, okay, where you would have some poles in the front here and in the back. Again, that's another triangular prism. And this shape here, anybody ever been to Billy Bees before, where you sit in this tube and it kind of rolls you around? I don't know if anybody knows what I'm talking about, but this is an octagonal prism. So this base shape has 1, 2, 3, 4, 5, 6, 7, 8 sides. So that's an octagonal prism. Think of that almost like a tire or a tube that you would kind of jump through. Volume formulas. Volume of a prism or a cylinder we're going to look at today goes like this. Volume equals capital B times H. Okay. Now this capital B actually means a little bit more information. So a capital letter, so notice our volume formulas have a capital V here. Okay, volume equals capital V, and I purposely put a lowercase h on there. B, capital B, stands for area of the base shape. So notice here on exercise 1, I gave you the base area is 50 inches squared. Okay, so you want to take the area of that base, and h is the height of the prism, which also I describe as the distance between the two bases. Right? So looking at exercise 2, we asked to find the volume of this three-dimensional figure. Okay, so here's my base shape is this hexagon. And if I kind of sketch in the back of it, okay, there's another hexagon back here. All right, but those two hexagons in the front and in the back are listed as a height from, oops, a little bit off there. The height from the front to the back is 6.5 inches. So our height is 6.5. The area of the base is 50. So again, this is a hexagonal prism. Volume of it would be capital B times H. So my capital B value is this 50. So we have 50 inches squared is how much this area of that hexagon takes up, times the height from that hexagon stacked back to this one is 6.5 feet tall. So a height isn't always vertical, up to down. All right, so we're not looking at how tall this stands. We're looking at how far it is from here to here. As you fill something with water, okay, this sanitizer by case, okay, if I'm holding it this way, all right, laying down on my desk right now, the bottom, the water level in the side here, it's kind of half, I don't know if you can see it, it's kind of listed this way. But when I tip this up, the water level goes from the bottom up to the middle here. Okay, so imagine standing this up sideways, a water level in this particular three-dimensional shape here would rise depending on how you're filling it from a faucet. All right. So with that said, volume equals area of the base times how high you're standing that base would be 6.5 inches. So the base is 50 inches squared, the height is 6.5 inches. So we're going to take 50 times 6.5. It's going to be 325 inches cubed. So volume is measured in cubic units, a length, a width, and a height. So we have, again, 325 inches to the third inches cubed here. And that comes from these inches squared times more inches. If I just look at the units, inches squared times one more inch to the first becomes inches to the third power, if you just think about the units. All right. Moving on to 2 more examples quickly, and then you guys can get started on your classwork. Exercise 3, identifying what type of shape it is. So that first page here, when you were finding what kind of prisms they are, okay, hexagonal, triangular, and so on, is important because now you have to identify it in order to know what formulas to be using. So what is this? This is going to be a triangular prism, meaning when we find the volume of this equals area of the base times the height, the base shape, since it's a triangular prism, the base shape is a triangle. So, sorry, that was sideways. All right, so how I like to substitute in here and think about this question is volume equals area of the base shape, meaning this triangle. Okay. So I keep outlining the base shapes for this reason. We need to find the area of that shape. Area of a triangle is half the base times the height. So what we need to do is find the area of that triangle. Well, we know the height is 8 and the base is 15, so we have to find a half of 8 times 15. So we have a half times 8 times 15 is really 4 times 15. The area of that triangle is 60. That area, let's put in our units, centimeters squared, is what replaces the capital B. So now we know how much space that area takes up. Now the next piece is to decide where my height is. So the height, again, is the distance from this base to the one back here. So the 13 is going to be how far that triangle is from the front of the shape to the back of the shape. So the 13 is our height. So subbing in, we have volume equals, our area of the base is going to go in as 60, the B. Okay. The height is going to be 13, and again, this is centimeters, this was centimeters squared. 60 times 13 gives me 780. Okay. So the volume here equals 780 centimeters cubed. Okay. So again, that first side work is we had to find the area of the base shape. So area of the base was at 60 centimeters squared. Last but not least, volume of a cylinder. Okay, so here's a cup, maybe not a cup, but 9 feet and 14 feet. This might be a silo. Okay, there might be like a rounded top to this, or maybe a cone top to this. Some future questions that we're going to see. So again, silo that holds grain. I'm thinking of a farm. Okay, so this again is a cylinder. And formula from your reference sheet, it's a page I kind of skipped in your packet already. You flip back 2 pages. The back of the front page in your packet is your Common Core High School Math reference sheet for New York State. Okay, so this is your New York State reference sheet. We're going to look at some of these conversions in the next few days. You might have seen a quart, liter, pint back in middle school math. But we have a bunch of formulas that I've kind of forced you to memorize along the way. Area formula, area of a triangle is a half base times height, parallelogram base times height. We talked about circles just a little bit. We have a whole other unit on circles coming up. But these next 4 formulas are what we're going to be using here in this unit. Okay, these general prism formulas. Okay, volume of a prism is capital BH. That's what we just learned. Today, right now, we're going to look at a cylinder question. Next class, we have sphere, cone, and pyramid. We're going to kind of go into. Right? So the cylinder formula says volume equals pi r squared h. And remember, r is your radius. H we know is height. So looking at your sheet, volume equals pi times r squared times h. So given the 2 dimensions, we know the h to be 9. Oops, sorry about that again. D is diameter. So that 14 is telling you across this circle here is 14 feet. So if the diameter is 14, the radius is half of that measure is going to be 7. So that's the number we're going to need. Okay? So volume equals pi times your radius, 7 squared, times our height, 9. Now there's 2 ways we're going to format this answer. Okay? We are going to round our answer to the nearest hundredth. And we're going to leave in terms of pi. So pi we kind of treat like a variable, like an x, okay? So I'm going to start with that, leaving in terms of pi first. Should have done these reverse order, but that's okay. In terms of pi, means we treat this pi symbol as an x. So this is x times 7 squared times 9. Now these numbers can be multiplied together. So I'm going to rewrite that as 7 squared times 9 times pi. It's really 49 times 9, and I'm just trying to do that out in my head. It's going to be 441 pi's. Okay? Now that's not in units. So since we had feet and we had feet, okay, pi is really a digit, right? So this is really saying 441 times 3.14 feet cubed. So that's our volume in terms of pi, right? Where we leave the pi symbol there. Okay? So 441 pi feet cubed. To the nearest hundredth is when we just type it in. So type into calc. That's what I'm going to write there. So if I put in pi 7 squared times 9, I can just type those digits right here. Pi times 7 squared times 9. Now I know pi is an irrational number, so when I type that in, it's going to give me all these funky decimals. Okay. Now my other answer I just had was 441 pi. Ooh, let's try that again, Miss Law. Pi 7 squared times 9 and 441 pi mean the same thing. They're equivalent answers. It's just two different ways to format it. Okay? So rounded to the nearest hundredth, I'm going to go 1,385.44. Okay? So 1,385.44 feet cubed is approximately the size of how many cubic feet fit into here. Now think of a cubic foot, again, as 1 foot across, 1 foot tall, and 1 foot wide. So 1 cubic foot is pretty big. It's hard to kind of box that in under this camera right now. To just show you, when you have a pyramid, the volume of a pyramid equals a third, capital B is area of the base, times the height, which is similar to what we were doing last class, volume equaled capital BH of a prism. So essentially, 3 of these pyramids would fit into a prism of that same size, right? If I were to kind of sketch in a triangular prism around this. Okay. So our ratio here is a third area of the base times the height. So capital B, again, is area of the base shape, and H is the height of your pyramid. Okay. And remember, that has to be perpendicular to the base. Okay. So looking at a little food pyramid here, okay, this diagram just says the base shape is 12 inches across. This stands from the top to the bottom, which will be our height, 15 inches high. Okay. So volume of a square pyramid. So the fact that they identified that it's a square means the base of this, if I kind of try to outline it three-dimensionally, okay, that base shape is a square, meaning it's 12 by 12. Okay. Because we really need 3 dimensions. So volume equals a third area of the base times the height. I'm going to kind of represent area of the base a little bit differently. A third times the side squared times the height. So again, if you think about a square with all 4 equal sides, a side times a side to find its area would be side squared. So subbing this in, a third times 12 times 12 gives me the area of this square on the bottom, times 15. Just going to type that in. Now, a third, 1 divided by 3. A couple of you were confused on how to put a fraction in. You literally just hit your division symbol. So 1 divided by 3 times 12 times 12 times 15 will give us a volume equal to 720 inches cubed. So that's volume of a pyramid. Volume of a cone. Again, I'm going to go back to my reference sheet here. Volume of a cone is very similar to the cylinder we did the end of last week. It's a third pi r squared h. So volume of a cone, switch colors here, is a third times pi times r squared times h. Now I'm just going to put parentheses around that pi r squared. That's the area of this circle. So looking at this cone, find the volume of a cone in terms of pi and round it to the hundredth. So we practiced that at the end of our last video, our class. 8 is going to be the radius here. And this other 8 is the perpendicular height of the cone. So from the top of the cone down to the bottom, thinking of a waffle cone here. Just toss some ice cream on top of that one, okay? So our formula, volume equals a third pi times r squared times h. Well, our radius and our height happen to both be 8. So volume equals a third pi times 8 squared times 8. Now, if we are doing this in terms of pi, we are not going to put the pi symbol in our calculator. So we're going to skip over typing that in. So 1/3 times, I'm skipping pi, 8 squared times 8 gives me 170.666. Now, typically when we write in terms of pi, we don't like decimals next to a decimal. Okay? So I'm going to hit Math Frac and change that to a fraction. So in terms of pi, this is going to be written as 5/12 thirds pi. And again, the units on this was inches, so it's going to be inches cubed. So that's our answer in terms of pi. Now, that would approximate to, so we're going to take that answer and we're going to multiply it by pi, which again is second up arrow. Sorry about that. Gives us about 536.16. Now, if you're looking at that 512 and you're going to 500, okay, don't get confused. That was divided by 3. So again, the answer was about 170. 170 3 times over does give us to about 540. Okay? So our final answer here is 536.1651. Rounding to the hundredths, please, is where our 6 is 536.17 inches cubed. So that's how many cubic inches we would fit into there. And just for reference, I just took out this little cube that I found. I say cube, it's more of a rectangular prism. If I measure it, it's about 1.5 inches across, about here. Okay. It's about a little more than 1 inch wide, and it's closer to 2 inches tall. This is about 1 cubic inch. So if I kind of chopped it here and made it a little bit more square, right? 1 inch up, 1 inch over, and so on. That would be 1 cubic inch if I chopped those two corners off of this brick. Okay? So for reference, 536 would be 500 little bricks. Right? Move on to another question. Exercise 3. We're putting two shapes together. All right. So looking here, we have a cylinder. There we go. So the volume of the whole solid as an exact answer. So exact answer is math terms for leave pi, or if you're talking radicals, leave the radical measurement in simplest radical form. Okay. So here we're going to add volume of the cone plus volume of the cylinder. So the formula for each of these is a third pi r squared h plus, for volume of a cylinder, is pi radius squared times h. Okay? So what I like to do with these questions is I first like to write down my formula. Now we're going to substitute. So we have to go over to the picture and decide what measures we have. So this 4 is representing a diameter. Now my formulas don't have a diameter, they have a radius. Okay? So the radius from the center out is going to be 2 centimeters. That radius is going to be the same here, from the base of the cylinder up to the top of the cylinder is going to be 2. So that's going to be the radius of our cone as well. So our radius will equal 2. Now there's 2 different heights, height of the cone and height of our cylinder. So we have to decide those 2 heights. Well, this 5 is how tall that cylinder stands. So this is the height of the cylinder, and height of the cone from here to here is going to be 6 centimeters. So just looking at the variables we have to substitute into, I know what the radius is, it's going to be 2. The height of the cone is 6. The height of the cylinder was 5. So I'm ready to substitute. So a third pi, radius is 2 squared, height of the cone is 6, plus pi, 2 squared, height of the cylinder over here is 5. Okay. I'm going to look at this as adding these or multiplying this out in terms of pi, multiplying this out in terms of pi, and then we're going to combine like terms across. So remember, when we're typing this in, we skip putting the pi symbol in when we're finding this in terms of pi. So we're going to have a third times 2 squared times 6. It's going to be 8 pi. A third times 2 squared times 6, and I brought the pi symbol down, plus 2 squared times 5, we know it's 20, 25. Now, does that answer make sense? Is the cylinder at the bottom going to have more space than the cone up at the top? It will, because it's a solid. It takes up all the space. Here, there's a lot of empty space on the sides of that cone. And that's going to combine to 28 pi total. And that unit was in centimeters cubed. So that's finding volume of 2 solids kind of put together. And you're going to have a couple questions like that on your classwork. Moving forward, there's some more complex ideas. So these diagrams I've been giving you have exactly the numbers you need for the formulas. Okay? Sometimes we're going to have to find a missing piece, and this Pythagorean theorem is going to help. So looking here, given the radius is 6.6 for this cone, centimeters, and the slant height is 12. So that's the height down this slanted side of your cone. Because if you had an ice cream cone, okay, and it was filled with ice cream, you could measure the outside of it, but you can't measure really the inside. That's a struggle. So the slant height here is 12 centimeters. But in order to find the volume of this cone, I would need to know the height, how high it stands. So we're going to use our Pythagorean theorem, because your radius compared to your height compared to your slant height makes this right triangle. So we're going to say 6.6 squared plus the height squared equals the slant height as your hypotenuse there. And then to the calculator, 6.6 squared gives me 43.56. Plus h squared equals 144. Subtract over, h squared equals 100.34. And we take the square root. And we're going to round to the nearest centimeter, so the height approximates to 10 centimeters. Typically, I do write out the whole decimal. I'm going to write 10.0219. That's why I'll leave that. So that's the height of my cone. Now we can go about finding its volume. So volume, again, equals a third pi r squared h. So again, if you need to go back, reread what you're looking for, again, we have a cone. Go back to your reference sheet if needed. Volume of the cone is a third pi r squared h. Okay? That's usually the most confusing thing some students do is they don't go back and check the reference sheets or double check what sheet they have. Okay? So pi r squared times h. So again, my radius was 6.6. Now to the nearest hundredth, I'm going to use the 4 decimal places. Okay. I don't like using one rounded answer for the next answer. Okay. Those decimals are significant, important. So 10.0219 is going to get multiplied here. And since we're asked to round to the hundredths place for this answer, I'm just going to type the whole thing in. Okay, I'm not going to skip pi this time. So 1 divided by 3, pi times 6.6 squared. As long as 6.6 is getting squared, the squared can be inside or outside of that set of parentheses, but then times that 10.0219. So our volume here will approximate to 457.1582. And again, rounded to the hundredths place is going to be 457.16 cubic centimeters, or centimeters to the third power. So again, you have to label a picture, understand what parts of the picture you need for your volumes, and go from there. So what we're going to bridge over into is some application questions right now. And there's going to be at least one on your classwork like this. So this question here, notice there's no picture drawn. Okay? So we're going to think about it. A Yeti tumbler is in the shape of a cylinder. Here we have a Yeti. It's filled 1 inch from the top of the cylinder with coffee. The height of the cylinder is 12 inches. So the height here is 12 inches, but there's only 11 inches of coffee inside. Okay. Its diameter is 5 inches. So the diameter they give us is 5 inches, which I know I'll need the radius is half of that, 2.5. Okay. So again, rereading this, a Yeti tumbler is in the shape of a cylinder. It's filled 1 inch from the top of the cylinder with coffee. The height of the cylinder is 12, and its diameter is 5 inches. State to the nearest hundredth the volume of the coffee in the thermos, in the tumbler. So volume of a cylinder is pi r squared h. I'm going to go hundredths. Now everything else was given to me in inches, so I don't have to make any unit conversions, so we're just going to substitute the measures we have. Our radius was 2.5, and it was only filled 11 inches high, because it was filled 1 inch from the top. Allow for that top to be put on. So in the calculator, pi 2.5 squared times 11. Now sometimes you'll notice I put the parentheses in, sometimes I don't. Pi times anything, or pi right next door to something, your calculator automatically multiplies it. So here our volume approximates to 215.9844. And rounded to the nearest hundredth is where our 8 is. So it's about 215.98 inches cubed. Part B. If a Keurig brews coffee at 100 inches cubed per minute, how long does it take the Yeti to fill? Round to the nearest minute. So 120 cubic inches per minute. That is a ratio. 120 inches cubed, or cubic inches, we write this a couple ways, okay, per 1 minute. How long does it take the Yeti to get filled? So this ratio, I'm actually going to flip-flop it to help ourselves multiply here. So we're going to start with how many cubic inches that Yeti needs. So we have 215.98 cubic inches. And we're going to multiply that by a ratio. When you need to multiply by a ratio, you want to end in an answer that's in minutes. Okay? So when we go to multiply two fractions, we need to have minutes as our answer and inches cubed cancel each other out. So when we multiply a fraction times another fraction, we're trying to eliminate these units. So what I'm going to do here is I'm going to say that 1 minute fills 120 cubic inches. So that when I multiply across here and here, okay, 215.98 over 1 and 1 over 120, we get 215.98 divided by 120 minutes. Now that I'm going to actually calculate it into my calculator. I'm not going to leave that as a fraction, right? So 215.98 divided by 120 gets us 1.79 minutes. And rounded to the nearest tenth of a minute is going to be about 1.8 minutes. So almost 2 minutes it's going to take for that Yeti to fill, okay, from the Keurig. So again, we divided here. So 120 cubic inches, we needed to cancel out cubic inches to cubic inches. So we ended up dividing those two numbers. We're going to do some more of these. And most of you would know that you rather multiply or divide those two numbers. If I took 215.98 and multiplied by 120, do you think it's going to take me about 25,000 minutes? It's not. And if you took 120 divided by 215.98, okay, do you think it's going to take a half a minute? Maybe 30 seconds. Okay. So that's where we have to kind of make the decision. But since it fills 120 per 1 minute, we have almost double that. So it should take 2 minutes. So that's our division. Our whole number divided by our partial. Number 6, we have a soup can. A soup can is in the shape of a cylinder. So how I draw my cylinders, I kind of skipped saying that in the last question. I draw an oval, and I just draw my two verticals, and maybe another smaller oval on the bottom. Okay. So soup can is in the shape of a cylinder, has a volume of 342 cubic centimeters. So we know that the volume takes up 342 cubic centimeters. It has a diameter of 6 centimeters. Express the height to the nearest tenth. So if we have our formula, volume equals pi r squared h, okay? Out of these three variables, the volume, the radius, and the height, I know these two. So I'm going to substitute in the 342 for the volume, and the radius is going to be for us 3, if that diameter was 6. So if I know 342 goes over here, equals pi times 3 squared times h, we're solving for the h. Okay. So I take my formula, I decide what values I'm already given in the question. So I was given these two digits, help me substitute into the v and the r. And now we're going to do some solving. Okay, we're essentially trying to get h alone. So we're going to make this pi r squared, pi 3 squared, disappear to the other side. Okay? So to get h alone when they're being multiplied, we're going to divide by pi 3 squared. So whatever I do to one side, I do to the other. But I'm dividing by this multiplied together. So pi 3 squared is really about 3.14 times 9. 3 squared is 9. So we're really dividing by a 27 here. So these parentheses are super important. So we're going to divide by pi 3 squared. Okay. So please, please, please remember these parentheses in your denominator. So what we're doing is we are dividing by pi 3 squared, cancels that out from here. So the right-hand side says the height is this division problem. Okay. So you're going to divide it out. So 342 divided by, my screen there, parentheses pi 3 squared. Now, how about we type in the real number, Miss? divided by pi 3 squared. Okay. So we're dividing by pi r squared there. And we get the answer of 12.0957. 12.0957. Okay. So that height is about 12.1 centimeters. Okay. So we're going to round to the 10th place. One other thing, if you remember your alpha y equals enter, you can bring up the fraction. Then you'll put the 342 in the numerator, the pi 3 squared in the denominator. You get the same answer. So if you remember how to pull up the fraction in your graphing calculators, depending on which one you're working with, that version might as well help you. So again, a fraction on your calc is alpha button y equals and enter. Now, moving into a grocery store, okay? They stack up soup cans on the shelves. Determine the maximum number of soup cans that can be stacked on their base between two shelves if the distance between the shelves is 14 inches. So if we have one shelf and its bottom shelf on a rack, okay, we want to know how many soup cans can be stacked high between those two shelves if that height between the shelves is 14 inches. Okay. So this is where we're going to use this whole answer here. So as I'm reading this, I think I have a typo. I believe I changed one of the measures here. Oh, inches. There's my typo. All right, 14 inches. This is measured in centimeters, okay? So we usually measure heights of these in inches. So what we have to do is some unit conversion. So 1 inch equals 2.54 centimeters. And that conversion is over here on your reference page. 1 inch equals 2.54 centimeters. So this is where you have to decide if you're going from a large unit to a small unit or a small unit to a large unit. So what we have to do is take our 12.1 centimeters and convert that into inches. So if we have 12.1 centimeters, we're going to multiply that by a scale factor. Right? This we're going to rate into a ratio is 1 inch to 2.54 centimeters. Okay? So 1 inch is to 2.54 centimeters. Or when we multiply these, okay, centimeters and centimeters will cancel each other out as units. So we get 12.1 divided by 2.54. 12.1 divided by 2.54 gives me, if you can see my calculator screen, 4.763. So this is going to be about 4.763 inches. So again, the soup can, if it measures 12 centimeters, it's going to be about 4. And I just had to pause, I'm sorry, to find a centimeter ruler next to an inch ruler. That seems about right. About 12 centimeters is almost 5 inches. Okay. So again, centimeters is here on this ruler, inches is on that one. So that's about right. So if you happen to have rulers in front of you, to take a look at that. But we need a shelf that's 14 inches high. So if it's 14 inches high, 14 inches divided by 4.76 inches, again, I'm keeping some decimals. So 14 inches divided by inches will tell me I can stack about 3 soup cans. So since my decimal here is smaller than 3, okay, that means the distance would be shorter than 14. So we can stack equals 2.9. So 3 soup cans will fit as a final answer here. Okay. Now we're going to get more into these unit conversions in the next few classes. Okay.